Hello everyone, welcome to the channel. So in this video, I'm going to show you identifying the drought severity using the time series analysis method by SPEI Dataset from 1980s to 2023 in Google Earth Engine for any study area of your choice. So now let's get started. So let me explain about the drought severity. So understanding the SPEI dataset. So the SPEI is in a multi-scalar drought index that considers both precipitation and potential evapotranspiration. This makes it a more comprehensive measure of drought condition compared to indices that only considers the precipitation. So this particular dataset offers a global drought time series data at different temporal scale from 1 to 48 months of temporal scales, and allowing for the analysis at various time frames. For example, you can consider for the short-term time frame or the medium-term or the long-term drought conditions. So identifying the drought severity, the drought classification, to classify the drought severity based on SPEI value. So we start with the mild drought, that is value ranges from -1 to -1.49. So we can consider as a moderate drought in case of the values varying from -1.5 to -1.99. And in case of extreme severe drought condition, the value ranges from -2 to 2.0 to -2.99. In case of extreme drought condition, so values SP values below -3.0. So the application of this particular SPEI dataset, so agricultural planning, use SPEI based drought assessment to inform the agricultural planning and water resource management. So the risk assessment, to assess the risk of drought in different regions, which is crucial for the disaster preparedness and mitigation strategies. And next is climate change studies, to analyze how the drought patterns have changed over time in response to global climate change. And last, policy making, so provides the data-driven insights for the policy makers to implement the drought management strategies and allocate the resource efficiently. So now let me get back to Earth Engine here. So to identify the drought severity for any study area using this particular dataset called SPEI, so first we have to define our region of interest. So to define our region of interest, we are using this particular dataset called HydroBASINS level 6 dataset to define the region of interest. So let me explain about this particular dataset here. So this is the dataset HydroBASINS level 6. So this particular dataset is a mapping product that provides hydrographic information for the regional and global scale applications in a consistent format. It offers a suite of georeference dataset at various scales, including river networks, watershed boundaries, drainage direction, and flow accumulation. So this particular dataset can be accessed using this particular script here, which is given. So we're going to copy this particular script, and we're going to access this particular dataset using the script here. So to access this dataset, we define a variable called watershed equals to feature collection WWF hydroshed version 1 basin high base 6. So to access the dataset, we are using this particular script here. And now to add this layer into Earth Engine, we define map.addLayer watershed, and this particular mentions the default visualization parameter and output the layer name as watershed. So let me I will show you the dataset here. So in the layer section, you can able to see that this is an output layer called watershed. So you can choose your study area of any study of your choice here. For example, I'm going to click this option called add a marker. So I'm going to select this particular marker here. I'm going to place a marker here. So you can able to see that I have placed a marker in this particular watershed boundary here. So next we're going to clip this portion of this watershed boundary, and we're going to perform the analysis for this particular watershed. So for that, we define this next set of things here. We define the coordinates of the point within the ROI. We define the variable coordinates equals to. So we have defined latitude and longitude of this particular study area. So you can able to see that. So we have created this particular marker, that is the point data here, which contains the latitude and longitude. Click this option called show generated code. So you can able to see the latitude and longitude. You can just copy this latitude and longitude of your choice of your study area, and can just replace this with this coordinates here, and you can get that particular watershed basin of your choice. So next we're going to perform the analysis. So next we define this variable called point of interest equals to geometry.point coordinates, which referring to this particular variable. So just we are referring this particular watershed based on this point data, and just we're gonna clip it out this particular, we're gonna select and clip it out this particular watershed basin to perform the analysis. So for that, we define this to filter the basin collection to get a specific ROI containing the point. We define the variable called ROI equals to watershed dot filter bounds the point of interest, which represents this particular variable here. And once you did that, it's going to output the layer. So we're going to define this map.center object ROI representing our region of interest. And next we're going to add this layer. We define map.addLayer ROI with the default visualization parameter and output the layer as study area. So now here you can able to visualize. We define this layer called study area. Let me click this. So now here you can able to see that we have managed to create a boundary, the watershed boundary of our choice from, we have extracted from the HydroBASINS, that is HydroBASIN dataset. You can able to see that. Likewise, you can select any basin of your choice using this particular way here. And next we're gonna load our SPEI dataset and filter to select a 12-month SPEI index from 1980 to 2023 time frame. So let me show you this particular dataset here. So this is a standardized precipitation evapotranspiration index database. So now here you can able to see this particular dataset availability. So this particular dataset availability is from 1901 to 2023. So it is available up to 2023. So the dataset provider is Spanish National Research Council. So they are the dataset providers. And next, to access this particular dataset, we can use the script to access this particular standardized precipitation evapotranspiration index. So using the script, you can able to access this particular dataset. So the description about the dataset: the global SPEI dataset database offers a long-term robust information about the drought condition at global scale with 0.5 degree pixel size and monthly cadence. It provides SPEI time scales from 1 to 48 months. So next we're going to check it out the bands that is available in this particular dataset here. So the resolution of this particular dataset is around 55,660 meters, and these are the different bands that is available here. So you can able to see here. So this particular dataset is so SPEI 02 months. So you can access the dataset for over a previous 2 months of datasets. And in case of here, towards this part of the section here, the SPEI of 16-month dataset, this particular band here, you can access the dataset of over 16 months of datasets. Suppose you want to perform a long time series analysis for the drought condition of your study area. So you can access this particular band here, that is SPEI 48-month here. So it has the standardized evapotranspiration index. So the precipitation evaporation data was accumulated over a previous 48 months. So in case you want to monitor a long-term drought conditions, so you can access this set of datasets here. So you can use this long-term datasets like 40 months and 20 months kind of datasets. Suppose you want to monitor only the short-term drought conditions, so you can use this particular set of datasets, that is from 2 to 16 months here. So you can access this particular sets of to monitor the short term. And in case of you want to monitor the long-term drought condition, you can use a set of datasets here. So this set of datasets has accumulated over 48 months of drought conditions. So in case you want to monitor the drought condition for each year, so in that case you can use this particular dataset, this band here, SPEI 12 months. So it contains accumulated dataset of drought condition for 12 months. So this is the band we're going to use in our particular data in the Earth Engine here. You can able to see that. So we define this to access this particular dataset. We define variable called SPEI collection equals to w.image collection CSIC SPEI 29 here. Using this particular code here, you can able to access this particular dataset, and in that we're going to select the specific band here. So for that we define dot select. So we are using the specific band, that is SPEI 12 months. So you can able to see that we are using this particular band here in this data set, and we're going to filter with the specific timeline here. So to filter with the specific timeline, we define the dot filter date 1980 comma 2023. This is the time frame we're going to perform our drought analysis from 1980 to 2023. So now to visualize this particular dataset in a time series chart here. So to plot the time series chart of the mean SPEI value over our study area. So we define this particular print UI.chart.image.series. So SPEI collection referring to this particular dataset here, and ROI which represents our region of interest, and to acquire the mean value of this particular stretch here over this particular timeline, we define EE.reducer.mean and define the spatial resolution, and this is the system start time, that is our start date. That is our start date here, which is mentioned as from 1980. So now you can able to visualize in the console section here. So you can able to see that here. This is our so I can able to see from this graph here. So the value of the drought severity ranges from -4 to +2 from 1980 to 2024. So we're going to visualize this here just by clicking here this option. So this is a graph of the drought severity from 1980s to 2024. So you can able to see here the positive values around, the highest values around positive plus, and highest level of negative values around -2.5, which indicates the severe drought severity. So you can able to see here this portion has a very high drought severity value. So it has around -2.3, and this particular value has -2.4. So now let me show you the drought severity values here. So the mild drought condition, so the values from -1 to -1.49. In case of moderate severity, it is valued from -1.5 to -1.99. In case of severe drought condition, it is from 2.80 to 2.99. In case of extreme drought condition, so the value should be below -3.0. So you can able to see from this graph here. So it is around, it has a severe drought condition based on this particular value in the month of this particular year in 1988 May 1. So you can able to see the date and the value here. So the value -2.4, which indicates the severe drought condition. In case if it's an extreme drought condition, the value should be below -3.0. So it is now a severe drought condition this particular study area faces in this particular time here. So towards in this part of the time here, it is around -1.6 in 2018 August 1, and now here in this situation here, it is the drought value is around -0.58 in May 2022. So from this graph here, which indicates that it is a mild drought condition in 2022, but it has faced an extreme drought conditions during 1988, and also in this time here in 2002, it has faced a severe drought condition. So comparatively in the 2022, it has faced only a mild drought conditions here based on the value here you can able to see here. So now next we're going to focus on the drought severity classification. So using our SPEI value here, so we're going to classify the drought condition into different drought classifications. So there is a many classifications given in the variety of literature survey. So based on the literature survey for this SPEI drought severity classification, so according to classification of McKee et al. 1993 and the Paulo et al. 2012 for the SPEI drought classes, we have 5 classes, namely the one non-drought. In this class, the value of SPEI is greater than -0.5, or 2 second class is mild. The value of SPEI values between -0.5 to -1, and the third class is the moderate SPEI. The SPEI is between -1.5 and to -1, and the fourth classification is severe, which is SPEI is between -2 to -1.5, and the extreme drought condition, which is less than -2. So based on these values, we can classify the drought severity of any study area. For this, you can classify this the data sets into different drought classes. So now in proceeding towards the drought severity classification, first we need to calculate the mean SPEI value for each image in the collection. For example here, so you can able to see in the console section we have the image collection. So here you can able to see that there is a list of around 516 elements. So let me show you that here. These are the different images that is available for this specific study region here. You can able to see that. So in order to obtain the mean SPI value for each of this image collection, so we define this particular variable called SPEI with mean equals to SPI collection dot map function image. So this referring to this particular variable we have mentioned here. You can able to see that. So in the next step, we're going to focus on to reduce an image to a mean value over the specified ROI here. So to reduce the image the mean value over the specific study region, we define this variable called mean value equals to dot number. So image referring to our SPEI image collection dot reduced region. So to obtain the mean value of value for the specified image, we define reducer reducer dot mean function. So we are specifying the region of interest, that is geometry. ROI represents our region of interest, and we mentioned as a scale that is around 55,000 meters. And last we have specified as a dot value function dot get 0. So we are using this specific function because to convert the dictionary values to a number, so we defined as a dot values function dot get number, so that is 0. So to convert the dictionary values to a number. So next next we're gonna set the mean SPEI value as a property of this image here. So previously in the property we can't able to see any mean SPEI value here. So in this set of codes we can able to see that. So first we define return image. Next we specify dot copy properties image referring to our image collection, and image dot property function here. Now dot set SPEI mean value. So now here you can able to see this. Let me type here print. So I'm gonna paste it here. So once you did that, we're gonna run this here, and we're gonna visualize the result. So I have made this mistake here. I'm gonna copy this particular one SPEI collection, and I'm gonna paste it here. And now we're gonna run this code. Let me click this option called run, and now we're gonna visualize the result. So you can able to see here. So this is our image collection. So we have created in the property sections here. So there is features around 516 elements. So in the feature section we're gonna click this, and gonna select one of this image here. So in the property section we have 5 properties like system asset size here, and we have this type coordinates, and system index and system start and end time here. So there is around 516 images that is available for the specific study area. So next to classify the drought severity based on the mean SPEI value, so we define this new variable called SPEI classified equals to SPEI with mean dot map function image. So next we define this variable called SPEI mean value. So to acquire the mean SPEI value for the each image, so we define this variable called SPEI mean value equals to dot number. So we are referring the earth engine dot number image dot get. So we're getting the SPEI mean value from this image. So for that we define dot get SPEI mean. So next to classify the drought categories based on the SPEI values, we define this variable called the drought classes equals to. So to classify this value we define dot algorithm dot if SPEI mean value dot less than -2. We are classifying it as a severe drought. And next category we defined dot algorithm dot if SPEI mean value dot greater than -2, and SPEI mean value is less than equal to -1. We defined as a moderate drought condition. And next we defined another set of category dot earth engine dot algorithm if SPEI mean value is greater than -1, and the SPEI mean value dot less than equals to 0, we defined as a mild drought condition. And the fourth category it is earth engine dot algorithm dot if SPEI mean value dot greater than 0, and SPEI mean value dot less than equals to 1 we defined as a normal condition. And last, to define the no drought condition, we define this doubly dot algorithm dot if SPEI mean value dot greater than 1, that is positive 1, we indicate as a no drought condition. And last, to set this drought classification as a property of this property of the image, to set the drought classification as a property of the image, we define as a return image. And to copy properties to that image, we define dot copy properties image dot property names. And to set the drought classes as a string. So to visualize in a graph with a different category indicating severe drought, moderate, mild, normal, and no drought condition, we are using dot set drought class doubly dot string drought classes. So we're gonna next rename the image in the collection based on the drought classification. So for that we defined a variable called drought classification equals to SPEI classify dot map function image. So we have defined this variable called class name equals to doubly dot string image dot get drought classes. So the drought classes referring to the different drought classes here. So to get this particular data, so we define this dot get drought classes. So now to return we define the return image dot rename as a class name, and to copy the properties we define dot copy properties image dot property name function. So to plot this particular the drought classification as a time series plot using so to plot this particular time series, so line chart of the drought classification over the time period from 1980s to 2023, we define this variable called drought series equals to ui.chart.image.series, and we are referring to the image collection here, drought collections, and the region, that is a region of interest, that is a study area. So to acquire the mean value, we define reducer doubly dot earth engine dot reducer dot mean function, and specifying the resolution of this particular dataset, that is 55 kilometers. And the properties, we are referring to the system start time. And to set chart type, we define this chart type is of line chart. So what we are using as a line chart here. So to set chart type, line chart, and we given a different name for this particular chart here. Based on the drought classification, we give dot set series name, mild drought, and moderate drought, no drought, normal condition, and severe drought. So based on that, we can give a colors to the different drought conditions. So for that, we define to give the colors. So we define dot set options, title, drought temporal classification, and the size of this particular point. We define 3 colors. These are the different colors we are using to indicate the different drought conditions, starting with the mild drought, which is indicated in gold color, and the moderate drought, which is light salmon, and no drought in green, and normal conditions are indicated in dark, and severe drought is indicated in orange red. And in the h-axis, we define the title as date, and in the v-axis, we define the title as a drought index. So to visualize this particular, we define print drought series. So we're gonna visualize it. Let me run this. So navigate is the option called run and click run. So it's going to generate our chart here. So you can able to see that different drought classification for this specific study area. So this specific study region. So from 1980s to 2023, you can see the different drought classification starting with mild, moderate drought, and no drought conditions, and normal drought, and last is we have the severe drought conditions. So let me click this option here. So we're gonna visualize it in the graphical. So we have 2 different axes. One axis which indicates the drought condition. The second axis which indicates the date. So starting from the year 1980s to 2023 here, which is indicated here. So still here it is 2022, and here it is 2023, and starting from 1980 to 2023. So from the color here, you can able to identify here. So the different colors indicates, for example, this particular color which identifies the mild drought in this set of years, which is you can able to see here. and in case of moderate drought conditions, which are indicated in this set of color here, and the no drought conditions, which are indicated in this color, and the normal drought. So the normal droughts are indicated in this, that is normal conditions are indicated in this color here, and last we have the severe drought. So the severe droughts are indicated in this set of colors here. You can able to see here in the 1988 we have a severe drought here. In December 1, 1987 we have a severe drought, and similarly in this setup here in the 2002 we have faced a severe drought condition in 2002 July 1. So you can able to see from this graph here. So this is drought temporal classification from 1980 to 2023 for the specified study region. So now we have seen the drought severity classification using time series analysis method from 1980s to 2023. So now let us see some applications of this particular analysis. So the application of the SPEI datasets here are the followings. The agricultural planning use SPEI based drought assessment to inform the agricultural planning and water resource management. Risk assessment assess the risk of drought in different regions, which is crucial for disaster preparedness and mitigation strategies. And climate change studies analysis how the drought pattern have changed over time in response to global climate changes. And policy making provide the data driven insight for policymaker to implement the drought management strategies and allocate the resource efficiently. So let me get back to Earth Engine here. So in this video I have shown you how to identify the drought severity using time series analysis method by SPEI datasets from 1980 to 2023, any study area of choice in Google Earth Engine. So the codes are given in the description. So thanks for watching, and make sure that you subscribe to our channel and give us a like.